Okay guys, so now let's move to question 10.1.3, and the question reads as follows. Calculate the potential difference across the resistors in parallel. And this question is allocated 3 marks. So now we're moving to 10.1.3. So remember, I think if you can check on the formula sheet, we've got a formula for calculating power, which is P is equals to voltage squared over R. Okay, a good question asked. So remember guys, on the circuit, it was indicated that we've got a power of 50 watts. Let me just quickly check that statement. So the total power dissipated in the parallel part of the circuit is 50 watts. So I've just calculated the total resistance of not necessarily the total, but the effective resistance of the parallel combination, which is 4.29. And I also have additional information on that parallel connection, which is the power dissipated. So the total power is 50 watts. So now I've got two things that I know about this parallel connection, which is the power, the total power dissipated. I also know the effective resistance of that parallel combination. So I can obviously calculate the voltage. So that's why I went straight to this formula, because I've got enough information to calculate the requested voltage. So remember, the potential difference, it's actually the voltage across the resistors in parallel. So I just need to calculate that V. So okay, we've got 50, which is the power dissipated in the parallel combination. It's equals to V squared over R. I've just calculated. So I just cross multiply. This is 50 over 1. So I've got V squared, which is equals to 50 times 4.29. So this is equals to, let's see, it's 50 multiplied by 4.29, which is equals to 214.5. So remember, this is equals to V squared. So now I need to get rid of that squared. That's where I introduce a square root on both sides. So that means it's equals to, can just say the square root of answer. Okay, it's equals to 14.65 volts. So I'm not sure if I was too fast, guys, but then I don't mind slowly explaining this question. Okay, so I think we'll just try to do the marking as we slowly explain this question. Okay, so remember, this question is allocated 3 marks. So I'm gonna show you where you score your 3 marks, and at the same time explaining, actually re-explaining how to approach this question. So remember, you're required to calculate the let me do this, the potential difference across the parallel combination. So it's more like you are calculating for that voltage connected across the parallel combination. So you've got enough information for this parallel connection. You were given the power dissipated there. You calculated the effective resistance of these two resistors connected in parallel. So you are now expected to calculate the potential difference across the resistors in parallel. So that means you go to the formula sheet, look for the relevant formula, and you notice you've got power, you calculated the resistance, and you are expected to calculate the potential difference. So you substitute your power, you substitute your calculated resistance of the parallel combination, then you just solve for V. You cross multiply, you've got your 50 multiplied by 4.29. Then the answer that you get, which is 214.5, you introduce a square root on both sides so that you remove the square on that voltage. Then the square root of this answer is equals to 14.65. So that means for let's see, that means the voltage, the reading on the voltmeter there, it's, let's see, it's 14.65. So you score a mark. We can just give you a mark for choosing the correct formula, and you know obviously the next mark comes from correct substitution, and your last mark comes from the correct final answer with the correct SI unit. So that's basically how you score. Let's see how many marks. That's how you score 3 marks on this question. So I think this question wasn't that much difficult. You know, as I solve this question, there's something that I realized in physics, that it's actually all about choosing the right formula for the question, correct substitution, then you follow mathematical procedure to solve the question. So you should be good in math. You don't necessarily need to be that good with maths, but you need to know the basics so that you'll be able to then proceed with calculations after correct substitution. So even for those who are not that much confident with their maths, they can still survive and get few marks, because as you can see, and as I've indicated from my experience, it's about identifying the correct formula and a correct substitution. Then the last mark comes from your final answer. So that's why I'm saying, if you can make sure of choosing the right formula and then substitute correctly, even if you don't get the correct final answer, but you'll still score some marks from the formula and correct substitution. But it's of utmost importance that you know how to solve for the unknown so that you score maximum marks. Okay, so that's it for this question. I think let's see, what's the question. Okay, yes, again, I think you're right. You should be given marks for the formula. Remember, there are multiple ways to kill a cat, so I'm only showing you the basics, but there are some other ways in which you can not necessarily answer this question, but for some other questions you can still solve them differently. For as long as you've followed the correct procedure and you've got the correct final answer, then you will score a full marks. And also it will depend on which formulas you've used. Then that's when you'll be able to score marks from the formulas, correct substitution, and the correct final answer. For example, when it comes to I'll just give an example using the previous question that we solved. When calculating parallel resistance, there's this formula where you can just say R parallel is equals to R1 multiplied by R2 over R1 plus R2. If you substitute, our R1 was 6, R2 was 15, and then R1 at 6 plus R2 at 16. Let's see. Let's just quickly see. Let's see. It's over. Then it's 6 times 15 over 6 plus 15. I just want to quickly check if we're going to get the same answer, which should be 4.29 there, 4.29. It's equals to, can you see? So we still get 4.29 ohms. So which means if someone approached that question in this way, then you are going to get a mark there. Or remember, it was allocated 2 marks. But assuming that it was allocated 3 marks, you're going to get a mark for correct formula, a mark for correct substitution, a mark for final answer. So I hope that answers a question of, that question. So I think you now understand exactly how I mean. So it doesn't necessarily mean that the way in which I answer these questions, that's how for everyone should answer the question. There are ways in which you can answer this question and still score maximum marks. Okay, so guys, without any waste of time, let's just move to another question. I'll just do a separate video for 10.1.4.